This is an optimization problem involving price and demand. A wholesaler finds that the weekly demand Q is a linear function of price P, and a graph of Q versus P is shown. When the price is $13, the company sells 396 units. If the price increases to $25, then they sell 300 units. What would be the revenue generated at a price of 0? Okay, so let's start with the revenue formula. R equals Q times P. The idea being that you charge a certain amount for each unit and multiply by the number of units to get the amount of money, the revenue coming into your business for the sale of the product. Now we'd like to have revenue as a function of just one variable if possible. And so what we can do is we can find that linear equation that's graphed right here. First I'll get the slope of it using delta Q over delta P. So they said that at $13 they sell 396, at $25 they sell 300. So let's go ahead and do the change in Q over the change in P. I get -8 for that slope. And that means we could write a function Q as a function of P equals M times P plus QO. I'll plug in the slope. And from the graph, I can see that the initial Q would be 500. So when they're asking us for revenue, we now want to take the results that we got here and we'd like to plug them in for Q in the revenue function. All right, this is going to give us revenue as a function of price equals -8P plus 500 times P. All right, if we were to plug in a price of 0, then clearly that would make this revenue equal to 0 as well. And we can actually see that point on the revenue graph over here. It starts off at the origin. So if you sell the items for $0, you wouldn't have any money flowing into the business. But what would be the revenue generated at a price of 13? Now we're going to find R of 13. This one we'll have to actually plug in. I get 5,148. And that point would be somewhere around here. Now it asks, what is the revenue generated at a price of $62.5? Let's use the formula we created. comes out to 0. Now which point is this on the graph? It's the other side of the parabola. So what we see here is if we increase the price too much, then people won't want to buy the item, and therefore we'll have a very low revenue. Also, if we decrease the price to a very low amount, even though a lot of people want to buy it, we're just not making enough revenue. There's some ideal price to set, and we want to find out what that ideal price is. And so we'll use calculus to do it. I'll find the first derivative of the revenue function. I'll do it on the side. The revenue function was R of P equals negative 8P plus 500 times P. I'm going to distribute that P. And now I want to find dr over dP. We're going to optimize the function, so I want to set the derivative equal to 0. Now I want to solve. $31.25. Now we ought to be able to look at the graph and see that that is the location of the maximum of the parabola, because that's what we're looking for. We're looking for the max revenue. But now it asks us, what is the maximum revenue that could be generated? Now we'll just want to plug into the revenue function, plug in the price that we got. $7,812.50. And now the problem is complete.